Somewhere in a forest in Japan, there's a cedar tree that's been standing for nearly 2,000 years. And buried inside one of its rings from the year 774 is a signature of something that hit planet Earth so hard, scientists still can't fully explain what it was. This isn't a legend. It's not a theory pulled from a fringe blog. It's measured, peer-reviewed, and confirmed independently on 3 different continents. And once you understand what it actually recorded, you'll understand why some physicists consider it one of the most important open questions in modern astrophysics, and why it might matter a lot more to you personally than you'd expect. In 2012, a physicist named Fusa Miyake was studying tree rings at Nagoya University in Japan, measuring the radioactive carbon locked inside individual growth rings. Every year, a tree absorbs a tiny, predictable amount of carbon-14 from the atmosphere, and that amount rises and falls slightly with the sun's 11-year cycle. It's a slow, gentle rhythm. Miyake was mapping that rhythm ring by ring, going back centuries, and then she hit the year 774, and the rhythm broke. In that single year, the carbon-14 level jumped by more than 1%. That might not sound dramatic, but on this timescale, it's enormous, roughly 20 times bigger than the normal solar swing. It was as if several ordinary years' worth of cosmic radiation had slammed into the Earth all at once. Miyake published the finding in the journal Nature, and the paper ended with an admission that should make anyone pause. Neither a known solar flare nor a known nearby supernova could explain it. Naturally, the first question anyone asks is whether this was some kind of local fluke, a quirk of that one tree, that one region. It wasn't. Within a few years, researchers found the exact same spike, in the exact same year, in tree rings from Germany, Russia, the United States, Finland, and New Zealand. Then it showed up in coral reefs in the South China Sea. Then, critically, it showed up in ice cores drilled in Antarctica and Greenland in a completely different set of isotopes, beryllium-10 and chlorine-36. 3 independent physical processes on opposite sides of the planet, all recording the same instant in time. That's not a coincidence. That's a global event. Scientists now call it a Miyake event in her honor. And here's where it gets genuinely strange. 774 wasn't the only one. Going back through the tree ring and ice core record, researchers have now confirmed at least 6 of these events. One around 993, roughly 60% the size of the first. One around 663 BCE. 2 more, thousands of years earlier, around 5259 BCE and 7176 BCE. And then, in 2023, researchers analyzing an ancient pine tree pulled from a riverbed in the French Alps found the biggest one yet, dated to around 12,350 BCE. A follow-up study in 2025 used a new atmospheric model to size it precisely, and the conclusion was almost hard to believe. Compared to the largest solar storm of the modern satellite era, recorded in 2005, this ancient event was, and I'm quoting the lead researcher directly, over 500 times more intense. So what actually caused these things? The leading explanation, the one most physicists currently favor, is an extreme solar storm. Not a flare like anything we've directly observed, but something far beyond it, potentially 80 times more powerful in particle output than the largest storm ever recorded with instruments, the Carrington event of 1859. The logic makes sense on the surface. The sun already produces flares and particle storms. We just may have badly underestimated how big one can occasionally get. But there's a problem, and it's a real one, not a minor technicality. When a solar storm hits the atmosphere, it's expected to leave a specific chemical fingerprint in ice cores, a spike in nitrates. Researchers checked. Across 8 different ice cores, at both 774 and 993, that nitrate spike simply isn't there. To be fair to the solar theory, that particular fingerprint has since turned out to be an unreliable method in general. It's failed to show up even for storms we know for certain were solar, so its absence doesn't rule out the sun. But it also means the solar superflare. Explanation right now is a leading hypothesis, not a proven fact, and scientists have been careful to keep it framed that way. The alternatives don't fare much better. Some researchers proposed a nearby supernova, a dying star exploding close enough to bathe Earth in radiation. It's a great cinematic idea. Except a supernova close enough to do this should leave behind an obvious, glowing remnant, a nebula we could still point a telescope at today. Nobody has found one that lines up. Others proposed a gamma-ray burst, one of the most energetic explosions in the universe. Possible in principle, but the odds of one landing close enough to hit Earth this precisely, more than once, are vanishingly small. A comet encounter has also been floated and largely dismissed for lack of any real supporting evidence, which leaves us with the honest, if slightly unsatisfying, scientific answer. This is very likely something the Sun did. We're just not entirely sure how or why it doesn't match what we know about solar behavior. And in 2022, a team at the University of Queensland made that mystery even deeper, not shallower. Physicists Qingyuan Zhang and Benjamin Pope ran every confirmed Miyake event through detailed carbon cycle simulations and found something nobody expected. These events don't line up with the Sun's regular 11-year activity cycle at all. And several of them don't look like a single instantaneous explosion. They look like they unfolded over 1 to 2 years. In Zhang's own words, rather than a single flare, what we may be looking at is a kind of astrophysical storm, an outburst that plays out over time. Pope, reflecting on the result, called the implications very disturbing, specifically because it means we currently have no reliable way to predict when the next one might happen. So let's talk about why that actually matters, beyond scientific curiosity. If an event on this scale happened today, the consequences would be severe. For comparison, the Carrington event of 1859, a much smaller storm than any Miyake event, knocked out telegraph systems across 2 continents. In July of 2012, a storm of similar strength to Carrington actually crossed Earth's orbital path and missed us by about 9 days, a genuinely close call that barely made headlines. Government risk assessments have modeled what a direct hit would look like. Estimates from the National Academy of Sciences put the first-year economic damage of a severe geomagnetic storm at $1 to $2 trillion, with recovery potentially taking 4 to 10 years. A later analysis from Lloyd's of London put the ceiling as high as 2.6 trillion, with tens of millions of people potentially facing extended power outages. Transformers, satellites, GPS, the internet backbone, all vulnerable. And that's modeling a Carrington-sized event. A full Miyake event is a different order of magnitude entirely. Based on the data we have, researchers estimate the odds of another Miyake-scale event at roughly 1% per decade. That number is built on a very small sample size, so treat it as a rough estimate, not a countdown clock. But it is not zero, and it is not comfortably small either. There's one more thread to this story, back in the historical record itself. The same year as the first confirmed event, 774, an Old English text called the Anglo-Saxon Chronicle records something odd in the sky. A quote, translated roughly as, "This year also appeared in the heavens a red crucifix after sunset." Some researchers think this is a description of an aurora, a visual echo of the same event the tree rings recorded, caused by charged particles slamming into the upper atmosphere. It's a genuinely compelling idea, but it's also contested. Other historians argue the timing and wording fit a lunar halo far better than an aurora, an optical trick of moonlight through ice crystals, not a storm at all. So that detail stays exactly where good evidence should leave it, intriguing but unconfirmed. So where does that leave us? The tree rings are real. The ice cores confirm them independently. 6 major events, at minimum, spread across roughly 14,000 years, each one a genuine, physical, dated fact. What caused each of them remains, honestly, our best guess rather than settled science. A solar storm far beyond anything we've directly observed, possibly unfolding as an extended storm rather than a single strike, with no reliable way yet to see the next one coming. If unexplained cases like this are why you're here, this channel exists for exactly this. Real, documented mysteries, told straight, with every uncertain part clearly labeled as uncertain. We've covered the WOW signal, a radial pulse from 1977 that's never repeated. We've covered the true story behind Apollo 10's strange in-flight recording. Subscribe if you want the next one when it lands. And before you go, here's the thought worth sitting with. Somewhere in the rings of trees still standing today, on every continent, is a permanent record of at least 6 mornings when the sky delivered far more energy than anyone alive at the time could have understood. We don't know when the next one is coming. We just know, eventually, one will. What would you actually want to know in advance, if you could? Let me know in the comments.